These are the solutions to the 2017 April QAS SAT Section 4 Math Calculator. If you want to look for this SAT, you can search and download it from reddit.com. Question 1 asks, if m is 3, how much greater is 10m than 6m? Now, the most obvious way to do this is to take the 3, plug it into m, plug it into m, get your numbers, and then subtract them. But that's actually not the fastest way to do it. The fastest way is to go 10m minus 6m is 4m, and then plug in m equals 3, and your answer is 12. C. Question number 2 says the temperature in degrees Celsius of a hot object is placed in a room and recorded every 5 minutes. The temperature of the object decreases rapidly at first. That means it's going to go down quickly at first, and then decreases more slowly as the object's temperature approaches the temperature of the room, and then it probably decrease more slowly again. And so if you look at this graph I just generated, or the shape of the graph, you can tell that it's A. Graph B is temperature increasing, so is graph C, and graph D is the temperature decreasing slowly at first and then faster later on. Question 3, x minus 2 equals the square root of x plus 10. And you're asked which of the following values of x is a solution to the equation above. And we have choices of -1, 1, 4, and 6. Now, mathematically, you could solve it if it asked you to solve it by squaring both sides. And then you would have to square out this binomial on the left, and the square root would disappear, and you could get the solution. However, if we don't do that, it actually makes sense to just look at the original question and figure out which one of the answer choices makes the most sense or is correct. And when you take the square root, it's nice to have a perfect square, a number that you can actually take the square root of. And so if we plug in the -1 here, we get a 9. And then that would be 3. But if I plug in the -1 here, I get -3. And -3 does not equal 3. This -3 does not equal 3. If I plug in the 1, I don't get a perfect square, so I cannot take the square root. If I plug in the 4, same thing. I cannot take the square root. If I plug in the 6, I can take the square root. The square root of 6 plus 10, and then that would equal 6 minus 2. 4 square root of 16 is 4, and so that works, and so the answer is 4. And that is C. Question 4 says last year 800 students attended the career fair at West High School. 800 students. This year, the number of students who attended the career fair increased by 5%. That means we multiply by 105%, which is actually the same as multiplying by 1.05, 800. And if you do that on a calculator, you will get 840. So the answer is B. Those answers, or those numbers, are actually simple enough that you don't need to use a calculator to do it. You can actually just take 5% of 800. 1% is 8, 5% is 40, and add it to the original amount to get 840. Question 5 gives us a table of seeds or nuts and calories, fat, and protein, all in grams, except for calories. The table above shows the calories of grams, fat, and grams of protein in a 1 ounce serving of the selected seeds or nuts. So we have 1 ounce servings. That's very important. Now you were asked in question 5, how many more grams of protein are in 1 pound of pumpkin seeds? So 1 pound of pumpkin versus 1 pound of pistachio. So the pumpkin has more than the pistachio. So what we could do is we could go 8.5, and then we could multiply that by 16 ounces, 8.5 grams. And then we could subtract 3.0 multiplied by 16 and get a number, and then we could actually do the subtraction. But that's actually the slower way to do it. So similar to a question that we just had, it makes more sense to go like this. The difference between 8.5 grams and 3 grams is going to be 5.5 grams. And so we're going to take 5.5 grams, and we're going to multiply that by 16 ounces. And this is 5.5 grams per ounce. The ounces end up canceling, and we get 16 times 5.5, which is just slightly over 80. So the answer is 88. You could also do it on a calculator if you wanted. C. Question number 6 says Lionel purchases 1 pound bags of each of the 5 seeds and nuts shown in the table. Of the following, which best approximates the average arithmetic mean number of calories per bag? And again, 1 pound is 16 ounces, which is a fact that everybody should know. So one way to do it is to take 198 calories for pecan, multiply it by 16 ounces. And the same for 80, and the same for pumpkin and sunflower and walnut. What makes more sense is to find the average of the number of calories and then just multiply by 16 at the end. So we have 198, and we have 80, and we have 159, and we have 166, and we have 185. And we're just going to add all those up and divide by 5. And that is 157.6. And then we take 157.6 and we multiply it by 16. And we get 2521.6. And so you can see that the answer is 2500, D, because it does say which best approximates. Number 7 says a pool initially contains 1,385 cubic feet of water. A pump begins emptying the water at a constant rate of 20 cubic feet per minute. Which of the following best approximates the volume, V of t, so our volume as a function of time, is equal to the initial volume, which is 1,385, minus 20 cubic feet per minute that we're losing, times t, the number of minutes. So we can see that it's A. The fact that t is between 0 and 69 minutes doesn't really have any relevance for this problem. The SAT likes to give us additional information to see if it confuses us. Question number 8. At a snack bar, each medium drink costs $1.85. And each large drink costs C more dollars than a medium drink. So a medium drink is $1.85. And we're told that we're going to buy 5 medium drinks and 5 large drinks. That means I'm going to take my $1.85, the cost of a medium drink, and I'm going to multiply it by 5. And then I'm going to add to it 5 times the cost of a large drink. And the large drink is C more dollars than a medium. And medium is $1.85. So we do $1.85 plus C. And when we buy those 10 drinks in total, we're going to get $20.50. So 20.50. Now, it is somewhat tempting to go 5 times $1.85, and then 5 times $1.85, and then 5 times C. But what I'm going to do instead is realize that I have 5 185s here, and I have 5 more 185s here. And that means I have 10 $1.85s, and that's $18.50. And this is actually much faster than using a calculator. Plus, don't forget, we also have 5 times C, 5C, and that's 20.50. And we can see that 5C must be 2, because 1850 plus 2 is 2050. So 5C equals $2. That means that C must equal 40 cents. Dollars 0.40. B is the answer. Question number 9. Kate bought a bus pass that had an initial value of $90. For every bus ride, Kate takes $1.80 the cost of one bus ride is subtracted from the value of the pass. What percent of the initial value of Kate's bus pass is the cost of one bus ride? That is kind of like scoring or receiving $1.80 out of $90. And to calculate the percentage, we just divide. We have 1.80 divided by $90. And we can see that we have an 18 here and we have a 9 here, and when we divide them, we're going to get a 2. And so the only answer that has a 2 in it is B. So the answer is 2% B. You can also do it on your calculator and you'll get the same thing. Question 10. To determine whether residents of a community would vote in favor of a ballot proposing to use 100,000 of local taxes for additional playground equipment at a community park, Jennifer surveyed, people at the park and found that 45 of those people would vote in favor of this proposal. Well, if you're trying to figure out if people like watching sports on TV, and you go to a sports bar where people are watching sports on TV, you'll probably get almost all of the people voting that they like to watch sports on TV, which will produce a biased result. And the same is true in this case. And so the answer is C. The sampling method is flawed and may produce biased results. Because if you go to people in the sports bar and ask them about a playground, they might not care. Question number 11 is one of these questions that looks very complicated, but is actually incredibly simple and can be answered in seconds if you just look at the question the right way. It has to do with the difference of squares. If you have x squared minus y squared, this will always equal x minus y times x plus y. But if you have x to the fourth minus y to the fourth, you will get x squared minus y squared times x squared plus y squared. Now, they've told you that x to the fourth minus y to the fourth is equal to negative 15. They have told you that x squared minus y squared equals negative 3. And they are simply asking you for the value of x squared minus y squared. So the question that remains is basically, can you answer this question right here? What is the question mark? Well, it's 5. So the answer is A. Question number 12 shows a graph of a cable company where the number of years since 1987 is on the x-axis and the percentage of households with cable television is on the y-axis. And remember, it's the percentage of households. It looks something like this, and there's a little squiggle in here, and it goes like that, and this is 54, which is the y-intercept. So my b value is 54, and that's my b value from y equals mx plus b. So if we look at the answer choices, the only possible equation that could be correct is an answer choice with 54 at the end as just a single number. 54 right here. So the answer is C. Now, question 13 says, which of the following is the best interpretation of the slope of the line of best fit? That's this slope right here. A, the actual increase. Well, no, because there's a percentage increase in this direction. So is it B, the predicted increase in the percentage of television, of households with cable television each year? Well, actually it is. Slope is always going to be, for every 1 year, every 1 on the x-axis, the increase here. So it's the increase in percentage each year. So the answer is B. Question 14. A greenhouse owner purchases fertilizer in 60-gallon drums. So we got 60 gallons. The fertilizer is mixed with water to make several batches of solution. Each batch of solution is made by mixing 3 quarts of fertilizer. So we got 3 quarts per batch. If we know how many quarts we have, we can just divide. Well, we do because we're told that there are 4 quarts in a gallon. So you got 4 quarts per gallon. The units of gallon cancels. So you have 240 quarts. And that is divided by 3, so you have 80. 240 quarts divided by 3 quarts is going to equal 80 batches. So the answer is C. Question 15 shows the following graph. This is 5 miles here and 0 miles here. Now it asks, says that Tara rode her bicycle, etc., etc., etc. How many total miles did she ride her bicycle? Well, if she started at 0 and she rode to here and then to here and then back to here, she rode a total of 5 plus 5 miles, which is 10 miles. Question 16. Ryan has 1,500 yards of yarn. 1,500 yards. He wants to knit at least 2 scarves and 3 hats. 2 scarves and 3 hats. Each scarf requires 300 yards of yarn. So this is 300 yards of yarn, and each hat requires 120 yards of yarn. Of course, scarves are much longer, so they require more yarn. If S represents the number of scarves, S, and H represents the number of hats, well, the amount of yarn that a scarf takes is going to be the number of scarves times 300. So we're going to have 300 times S is how much yard the scarves take, plus 120 yards per hat times the number of hats, which is H. And that has to be less than or equal to the total amount of yarn that we have, which is 1,500 yards. So what that does is it eliminates D. Nope, sorry. It eliminates everything but D. So the answer is D. Now, additionally, we're told that we're going to make at least 2 scarves. That means the number of scarves is going to be greater than or equal to 2, and at least 3 hats. So the number of hats is going to be greater than or equal to 3. But this is all you needed to know to solve the problem, because it's the only answer that had that in it. So solving this was actually unnecessary. Number 17, Michael tossed 2 coins, 1 dime and 1 nickel at the same time, and recorded the results. His results are shown. So we have 27, 26, 24, and 23. For what percent of those tosses did the dime Michael tossed land on heads? Well, these are the situations where the dime landed on heads. So we just need to go 27 plus 26 out of the total, which is 27 plus 26 plus 24 plus 23. And you might notice that these two add up to 100, or rather 50. And these two add up to 50. So we have, in the denominator, we have 100. And so in the numerator, we have 53, which makes it 53%. D. Number 18 is a unit conversion problem. I won't read the whole question, but it does ask for the drop in atmospheric pressure in millimeters of mercury. So we want our final units to be millimeters of mercury, and so we start with millimeters of mercury in the numerator of our fraction, or just as a standalone unit. But since we have a conversion, we're going to start with 760 millimeters of mercury per 1013 millibars. And because we don't want units of millibars in our answer, we're going to put millibars in the numerator of the next fraction. And then they will cancel. So we are told that the atmospheric pressure dropped 3.4 millibars per hour. So we're going to put 3.4 millibars per 1 hour. We don't want units of hours in our denominator either. So we're going to put units of hours in the numerator right next door. And we're told that it happens over a period of 5 hours. So there was actually nothing on the bottom here. We'll just put a 1 there. Hours, hours. And so when you do this calculation, you'll get your result, which is 12.75. So the answer is B, 12.8. Number 19 talks about a car dealership that starts with an inventory of 29 cars. And during the first 6 months, 18 additional cars were purchased each week. And at the bottom of the paragraph, they talk about T weeks. So we're going to add 18 cars per week times T weeks, but we're going to sell 15 cars per week for T weeks. And so our equation will be 29 plus 3T, because these become this. And so the answer is D. They try to trick us a little bit by switching the 29 and the 3T, although in a linear equation, it is always better to write the variable first. Question 20. 2 root 2x equals a, and they're asking for what is 2x in terms of a. 2x in terms of a, and what that means is very simple. It just means solve for 2x. That's all. And so to solve for 2x, we divide both sides by 2, and then we square both sides, and the squared and the square root cancel each other out, so we're just left with 2x, and that's what we want to solve for. So 2x equals a over 2 all squared, but we don't have that in our answer choices, and so we're going to distribute using the laws of exponents. The 2 goes to the a, the 2 goes to the 2, so it's a squared over 2 squared, and 2 squared is 4, a squared over 4, so that is B. Question 21 asks you to come up with an equation for all of the different arrangements. If you look at the drawings carefully, you will notice that for every single table, we have 6 seats. And then there are always 2 extras on the end of the entire arrangement, which means that if we have n tables, we're going to have 6 people at each one, but we're always going to have 2 additional people, 1 at each end. So the equation is 6n plus 2. But again, we don't see that in our answer choices because the SAT always likes to test to see whether you can factor. And well, yes, you can. You can undistribute a 2 from each of those terms. So 2 parenthesis 3n would give us 6n plus 1. So the answer is B. Number 22. The graphs in the xy plane of the following quadratic equations have x-intercepts of -2 and 4. So I'll make a quick sketch. -2 and 4. And the graph will go through it something like this. But it could also go through it like this or like this. And each of those drawings depends on the coefficient. So the larger the coefficient, the more stretched out the graph will become. So as this point moves downwards, it will move downwards based upon the number in front. So y equals, if we have an a value here, x plus 2 and x minus 4, the larger this number is, the further this will move. So the answer is A when this is a -7. Now, a -7 will actually cause the graph to do something like this, but they're talking about the distance, how far this is from the x-axis. It'll be the farthest when this number has the greatest absolute value. 23 is a question that can be solved in about 5 seconds if you do it the right way, or 50 or more if you do it the slower way. They give you these two equations, 2x plus 3y equals 5. 4x plus cy equals 8. And they ask for the value of c for the equations to have no solution. And no solution means these two equations, when graphed, will be parallel. And so you might think we need to put them in slope-intercept form, get the slope of both, compare them, set them equal to each other. And while you can do that, and I will show you how to do that, at the end I'll show you a super fast way to do it. So in this case, we have y is going to equal -2x plus 5, and then we're going to divide both by 3. And there's our slope. For the next equation, y is going to equal -4x plus 8, and then I divide both sides by c, divide by c, divide by c, and there's my slope. Now don't forget that when you have a plus b, or minus, plus or minus b, over c, this will equal a over c plus or minus b over c. And that's the rule that I used to do both of those problems right there, or to get both of those problems. Now, if I set the slopes equal to each other, I get -2/3 equals -4 over c. And then to solve for c, I can cross multiply, like this and like that. And I get 3 times -4 equals -2 times c. And now I have -12 equals -2c. And so c equals 6. And so my answer is D. And you might think, how could there possibly be a faster way to do it? But there is, and it's an amazing way. If you simply have these equations where the x's here, the x and the x are above and below each other, the y and the y are above and below each other, and you have a constant above and below each other, there is a very simple way to do it. You take these numbers in front of the variables, including the sign. You include the sign. And then you take these numbers or variables in front of the letters, in front of the x and the y. And you simply cross multiply. So you get 4 times 3 equals 2 times c. And you can immediately see that c has to equal 6. And this comes from the idea of using matrices to solve the system of equations and then finding the determinant of the so-called coefficient matrix. When the determinant of the coefficient matrix of these two linear equations is equal to 0, there's no solution. So when these cross products are equal to 0, or equal to each other rather, when these cross products are equal to each other, there's no solution. So the answer is 6, and that's super fast. And it will always work for this type of problem. Question 24. The polynomial p to the fourth plus 4p cubed plus 3p squared minus 4p minus 4 can be written as, well, this is the part that we care about, p squared minus 1, p plus 2 squared. What are the roots of the polynomial? Well, roots happen when you set something equal to 0. We're looking for the values of p that make the equation true. This one here is a difference of squares, p minus 1, p plus 1, and then we have our p plus 2. And we can expand it out and go p plus 2 again. And you can see that this one needs to be equal to 1 for the equation to be equal to 0. This one needs to equal -1, and this one needs to equal 2. And that would also need equal 2, but since we have double solutions, we just use one of them. And so these are the solutions. 1, -1, and 2. The answer is D. Number 25. Which of the following describes an exponential relationship between the pair of variables listed? For every 3 millimeter increase, m, in the thickness of a piece of glass, the intensity of light, I, traveling through the glass decreases by 20%. So the light will decrease by 20%. That means the amount of light is going to always be multiplied by 0.8. And if you only have one 3 millimeter increase in thickness, you'll multiply by 0.8. If you have another 3 millimeter increase in thickness, you'll multiply by another 0.8, and then by another 0.8. And so because we keep multiplying by the same number again and again, this is an exponential function. And so we're lucky, and the answer is just A. For all of the other ones, they talk about a constant rate. They're all constant rates, so all the other ones are linear. In number 26, we have some information about a researcher investigating the relationship between the price of a 4-pack of AA batteries at a convenience store and the number of competitors the store has. And we're given this chart. Let's just jump to the question. It says that another convenience store in the same state sells a 4-pack of batteries for $4.89. So what I've done is I've plotted $4.89 is about $4.90, so it's going to be right about there. And then it asks, if the store's price is more than the predicted line of best fit, what is the least number of competitors the store could have? Well, if the store had 2 competitors, we'd be right about there. If the store had 1 competitor, we'd be right about there. Here, we could also be here with 4 competitors. And the answer is this point, because this is the point that has the least number of competitors, only 3 competitors, but is above the line of best fit at about 489. So the answer is C, 3 competitors. Now number 27 uses the same graph, and it says that the line of best fit, which is this line right here, the line of best fit passes through the point 18, comma, -0.12. Which of the following can be concluded from this? Well, first of all, 18 is going to be the number of competitors because it's the X value. So we're going to be way, way over here somewhere at 18. And this is $3 here, and then we probably have $2 here, and $1 here, and then $0 here. So we're going to be somewhere down here at 18 competitors, and the price is actually below $0. And that doesn't really make sense because no one's going to sell batteries for less than $0, which means they're effectively paying you to buy batteries. So this graph is probably going to do something like this, and it's going to start to level off realistically. No matter how many competitors a store has, you are not going to see that price fall below some certain amount because you have to buy the batteries and you're probably not going to sell them for below your cost. Otherwise, you might just not buy them in the first place. And so let's look at the choices. The line of best fit will not model the price well for a store with a large number of competitors, and that's the one. So it's A for 27. We could look at the other ones, but A is definitely correct. Let's just look at them. B, a convenience store with 17 competitors can no longer sell 4 packs of batteries. No, they can sell them if they want. A competitor with 17 competitors cannot decrease its price any further. Well, they can always decrease their price as much as they want. They just might lose money. And a convenience store cannot have more than 17 competitors. That's not true either. So the answer is A for 27. Question 28 shows the following diagram. And it says that the figure shows that the shaded triangular region with a hypotenuse of 5 has been removed. Of the following, which best approximates the area in square centimeters of the tile before the piece was removed? Now, since this is a 30-degree angle, and this is a right angle here, right there, that means this is a 60-degree angle. And if that's a 60-degree angle, and this is a 90-degree angle, We have a 30-degree angle here. We have a 60-degree angle here. That means we have a 60-degree angle here. And since we have a 90 here, then we have a 30-degree angle there. So all of the triangles in the region we're concerned about are 30, 60, 90 triangles. And when you have a 30, 60, 90 triangle, 30, 60, 90 triangle, if this side is length A, this side is length 2A, this side is length A times root 3. That means if you jump from this side to that side, you multiply by root 3. But if you jump from this side back to this side, you divide by root 3. If you jump from this side to this side, you multiply by 2. If you jump from this side back to this side, you divide by 2. So we want to jump from this side, and we want to get this length right here. So that length is simply going to be half. We're going to divide by 2, so this length here is 2.5. Now when we jump from this side to this side, this becomes 10 because it's just double. And when we jump from this side back to this side, it becomes 5. We cut it in half. So we're back to our 5. And when we jump from this side to this side, we're going to multiply by the square root of 3. So this side is 5 root 3. So how big is the original rectangle? Well, it's the sum of 2.5 and 5. So it's 7.5 times 5 root 3, which equals 64.95. So 65, and the answer is D. Number 29 shows the following drawing where the light gray shape is supposed to be a regular hexagon. So all of those sides are the same length. All the highlighted gray sides are the same length. And they are all length 4. So that's 4, and that's 4. And so is that. All of them. They're all 4. In a hexagon, if you connect the vertices to the center, we will have a total of 6 triangles. And that means that each of these is 60 degrees. And because these are all the same, each of these is 60 degrees, which makes this also 60 degrees, 60 degrees, 60 degrees, and so this is 60 degrees right here, and that's a right angle. So this is 30 degrees. Now if this is 4, then we can just multiply the hypotenuse by half or divide by 2, and we get a length of 2 right here. So this is a length of 2. And then we go from this one to that one by multiplying by root 3. So that's 2 root 3. So we have a triangle that is 2 by 2 root 3. But we have 4 of them. So we're going to have another one here. This one would fit right in there if we flipped it. And so we have a rectangle that is 2 by 2 root 3, and we have 2 of them. So we have 2 times 2 root 3 times 2 of these rectangles, and that's 8 root 3, and that's our answer. A. Now we could also do this by looking at this triangle right here and saying, okay, we have 4 of these triangles, and the area of a triangle is 1/2 times the base, which is 2, times the height, which is 2 root 3. And that's the area of one triangle, but we have 4 of those triangles. One here, the initial one, and then one right here. So the half and the 2 cancel, and we end up with the same number. A equals 2 times 4 is 8 times root 3 is 8 root 3. Question 30. Last question of the multiple choice. says, which of the following equations describes a circle with a radius 10 that passes through the origin when graphed in the xy plane? Let's remind ourselves of the equation of a circle. X minus h squared, where h is the horizontal shift, plus y minus k squared, where k is the vertical shift, equals the radius squared. That means the center is always going to be at h comma k. So A has a circle. So A has a circle with a center at 5, negative 5, because this k value has to be negative 5, so that when we subtract it, we get y plus 5. So if we draw that circle, we'll be at 5 and negative 5, and we'll be right here. Now the radius is 10, which means that our r is 10, and our r squared is 100. So actually, we can ignore A completely because, well, it equals 10, not 10 squared, which is 100. However, B has the same shift. So B has the center in the same place. B, this one doesn't work, 5 comma negative 5. What is the distance to the origin? Well, if this is 5, that means this is also 5, because this is 5, this is 5. So we're right here. We have a 45, 45, 90, which means that you get the hypotenuse by multiplying by root 2. You would also go backwards and multiply by, or rather divide by root 2. So this length here, the radius, is going to be 5 root 2. 5 root 2. And so we know that this is wrong. C has a center of 10 and 10. That's going to be here, here, and there. So this distance is 10. This distance is 10, which means that the radius is going to be more than 10. So C is wrong. That means that D must be correct. We can also check D if we want, although we don't have to. We have a center of 5 root 2 and negative 5 root 2. 5 root 2 is about there, and negative 5 root 2. 5 root 2 is about there, and then negative 5 root 2 is about there, so we'll be around here. So this distance is 5 root 2. This distance is 5 root 2. And our radius, we have to multiply it by root 2. So 5 root 2 times root 2 is going to be 10. Multiplied by root 2, we get 10, because we get 5 times root 2 times root 2 is root 4, which is 2, and that will equal 10. So the answer is definitely D. Question 31. In the xy plane, the graph of y equals x minus 6 squared plus 3 is the image of the graph y equals x plus 5 squared plus 3, after a translation of how many units to the right. So the graph y equals x plus 5 squared is going to be shifted 5 to the left. So it's going to have a center line here. Its axis of symmetry will be 5 to the left. And the graph of y equals, in parentheses, x minus 6, that will have a center line that is shifted 6 to the right because of the minus 6. And 5 and 6 is 11, so it'll be shifted 11 units to the right. The answer is 11. Question 32. When 9 is increased by 3x, the result is greater than 36. There it is. And the question is, what is the least possible integer value for x? Well, if they were equal, then x would be 9. X would equal 9 if equal. But 9 plus 3x must be greater than 36. So if we do x equals 10, then we get 9 plus 30, and that's definitely greater than 36. The answer is 10. In question 33, we are given the following chart. Century and regions of United States president's birth as of 2014. This is the century here. We have the 18th century, the 19th century, and the 20th century. And we have 5900, we have 6490, and we have 3322. They ask. The table above shows the distribution, etc., etc. Based on the information in the table, what fraction of the presidents who were not born in the 19th century were born in the South? That's the same as saying what fraction of presidents who were born in the 18th and 20th were born in the South. So we're going to scribble this out. We're not going to use that. So we're looking for South. So that's 9 plus 3, which is 12, out of the total, which is going to be 5 and 9 is 14, plus 6, 20, plus 4, 24. So it looks like 1/2. You could also grid in 0.5. Question 34 says if x does not equal 1, what is the value of 1 over x plus 1 times 2 plus 2x? You should immediately notice that 2 plus 2x can be factored. So if I factor 2 plus 2x, I get 2 parenthesis 1 plus x. I still have my 1 over x plus 1. Now 1 plus x is the same as x plus 1. So these cancel, leaving me with 2 times 1, which is 2. So the answer is 2. Question 35 says that we are going to be buying 10 tickets. What is the average price of the ticket? We are told that we will be buying 3 tickets from row 1. So we're going to have 3 tickets from here. That's going to be $75. We will be buying 2 tickets from row 3. Well, row 3 is $20, so that's going to be $40. And 2 tickets from row 4, also $20 each, so $40. And then 3 tickets in row 12, and so that's going to be $45. If we add 75 to 45, we get 120. And these make 80. So the total is 200. Divided by 10 tickets is $20 per ticket. Question 36. A fashion buyer for a large retail store purchased 315 items. 315 items. Directly from the manufacturer for a total of $6,000. Some of the items were dresses purchased for $25 each. So this is going to equal the number of dresses plus shirts purchased for $10 each, the number of shirts. Now the total cost of dresses and shirts is going to be $25 times the number of dresses plus $10 times the number of shirts. Now we have a set of linear equations written in standard form. I'm going to ignore the dollar sign for now. I'm going to multiply this upper equation by 10. Perhaps I'll multiply it by -10, and then I can add the equations. The 10 distributes to everything, leaving me with 3,150, except that's negative, minus 10d, and minus 10s. When I add the equations, these are gone, and I get 15d, and I get 2,850. And I need to just divide to get the number of dresses. So the number of dresses equals 190. So now let's not forget that d plus s is equal to 315. D is 190, so S is equal to 315 minus D, which is 315 minus 190. So the number of shirts is going to be equal to 125. And so the difference between 125 and 190 is going to be 65. You do 190 minus 125 equals equals 65. So how many more dresses than shirts did the buyer purchase? 65 more. Number 37. An instrument shows the number of revolutions per minute made by each tire of a car. In each revolution, the car travels a distance equal to the circumference of one of its tires. And the circumference of each tire is equal to 2 pi r. Most of this we should already know. If the radius of each tire in Maria's car is 0.3 meters, r equals 0.3 meters. What is the approximate speed of Maria's car to the nearest kilometer an hour when the instrument is showing 779 revolutions per minute? This sounds pretty complicated, but remember, when you do unit conversions, you always start with the numerator of the units you want in your answer. So we want kilometers per hour in our answer, so we're going to start with kilometers. The unit conversion of kilometers, we're going to do kilometers per meter. Because we want kilometers per hour, so we start with kilometers in the numerator. 1 kilometer is 1,000 meters times. Well, we need to now know the circumference of the tire. So the circumference is 2 pi r. So it's going to be 2 pi r, which is 0.3 meters. So it's that circumference per 1 revolution. Meters cancel meters times 779 revolutions per minute. So we put revolutions next so that it cancels. That's 779 revolutions per minute. Now I have kilometers per minute, but I don't want that. I want to multiply by 60 minutes per hour. Minutes cancel. And when I multiply everything together, I will get my answer, which is 88 kilometers per hour. Last question, 38. Maria gets new tires for her car. The radius of each of her old tires is 0.3 meters, and the radius of each of her new tires is 11% larger than the radius of her old tires. What is the circumference of each new tire to the nearest tenth of a meter? Well, it's going to be the old circumference times 1.11 for 11% larger. This is the 11%. Now you might remember that the circumference is 2 pi r. R is 0.3. And we multiply by 1.11. And when we multiply all of that together, we get 2.1. 2.1 meters is the circumference of each new tire.